I'm going to work out a couple examples just to illustrate these ideas for slope and the equations of lines and finding the equation of a line. So let's look at this example. You got 3 points. Do they all lie on the same line or not? Well, you could find the equation passing through, for instance, the first couple of points and then check if the third one lied on there. But it's easier just to look at the slopes between the two pairs of points. So for instance, group the first two together, group the second two together, and check. Are the slopes the same or not? This falls in line with our similar triangles idea. All right, so compute your slope from your slope formula. You take the y components, subtract them, the x components, subtract them, compute the number on top. You get 15 over 105, which gives you 1/7. Okay, now do the same thing for the second point. You're going to do 12 minus 1 over 98 minus 21. Difference in the y's divided by the difference in the x's. And then you compute, you get 11 over 77, which gives you 1/7 as well. Okay, so therefore, thinking about the similar triangles, connecting those points, those triangles are similar, and therefore the slopes are similar, and therefore, yes, they lie on the same line. Okay, now let's look at this example. How do you find the equation of the line with slope -3 that's passing through the point -1, 3? All right, so we had two equations. One, the point slope formula, and we also had the slope-intercept formula. I'm going to illustrate using each one. All right, first, using the point slope formula, we know the slope is -3. Okay, so we're going to plug in m equal -3 into the formula. Y minus y1 equals -3 times x minus x1, and we have a point on the line. We're going to plug -1 in for x1, 3 in for y1. All right, let's put parentheses around the numbers just for emphasis. It makes a difference though when you write down the x component one, because it's going to be x minus -1. All right, and that subtraction is going to turn into addition. So we get y minus 3 on the left is equal to -3 minus or times the quantity x plus 1. Right, and that's one of the forms that we're going to use, the point slope form. The other one, the slope intercept form, well, we know the slope again, so we can put in x equals, or m equals -3. And then our equation's y equals -3x plus b. And our job is remaining to find this other constant, which is b, our y-intercept. All right, now to do that, remember, the graph of an equation is just this set of solutions. There's the picture of the solution set. So any point that's on the graph has to satisfy the equation, and vice versa. Any solution of the equation has to be on the graph. All right, so we know one point that's supposed to be on the graph, -1, 3. All right, so plug in 3 for y, -1 for x, and that equation must be satisfied. All right, so simplifying, you get 3 equals 3 plus b. All right, solving for b, we get that. Turns out b is equal 0. So you cross the y-axis at height 0. You cross through the origin. So your equation of your line is y equals -3x. That's it. Now these equations are actually equivalent to one another. If we solve this equation for y, we would get y equals -3x. So either form is acceptable, the point slope form or the slope intercept form. Okay. Now move on to this example. We want to find the equation of the line passing through the points -4, -7, and 5, 11. So again, we're going to either use the point slope formula or the slope intercept formula. Again, I'll do them both for this example as well. All right, for each of these formulas though, we need the slope. All right, we're not given the slope, so we actually have to go and find it. So we need to use our slope formula, rise over run, difference in the y components divided by the difference in the x components. So for this, we're going to call this one x2, y2, this one x1, y1, and then you look at your ratio. You get 11 minus -7 divided by 5 minus -4. Simplifying on top, be careful with the minus signs. All right, you get 18 over 9, which is 2. All right, so our slope is 2. Now we're going to need that whether we use the slope intercept form or the point slope form. All right, so plugging into the point slope form, we get y minus y1, let's call this point x1, y1, equals 2 times x minus x1. So it's x minus negative 4. Again, be careful with the negative signs here. It's really important. So this is going to change over to y plus 7 is equal to 2 times the quantity x plus 4. And that's one form of the answer. Or you could use the slope-intercept form. So we computed the slope before, got 2, so we plug in m equals 2. And then we got to remember, just like the last example, that we have to plug a point in to find the b. We can use any point that we know is on the graph of our equation. So that's going to say for us, we can use either one of these points. We can put negative 4, negative 7 in for x and y, or 5, 11 in for x and y. The equation has to be satisfied. So just to avoid the negative, I'm going to plug in 5 and 11. So 11 for y on the left, 5 for x on the right. Simplify, you get 11 equals 10 plus b. Solve the equation for b by subtracting the 10 over, and you get b is equal to 1. So we conclude that our equation is y equals 2x plus 1. And again, that will be equivalent to the equation we found using the point slope form.